A 1.5 volt cell is connected to a switch S, a neon lamp, and a coil with many turns as shown. Nothing is observed when the switch is closed, but the neon lamp flashes as soon as it is opened. We are also told that the neon lamp flashes when the potential difference across it is about 200 volts. We need to use Faraday's law to explain why the lamp flashes once when the switch is opened. When the switch is closed, there is a current flowing through the circuit, which goes through both the coil and the lamp. Given that the lamp is in parallel with the cell, the potential difference across the lamp is 1.5 volts. And this is not enough for the lamp to operate, which requires at least 200 volts. And that's why we don't observe anything in the circuit. However, we have got a current flowing through the coil, and that generates a magnetic field around the coil. When we open the switch, the current will stop flowing. So we don't have the current, and as a result, the magnetic field will also disappear, because the current was the reason the magnetic field was there. We no longer have a magnetic field. And given that opening the switch takes a really short time, this happens really rapidly. So why does this make the lamp flash? We need to remind ourselves what Faraday's law is. And Faraday's law says that the EMF induced is equal to the rate of change of magnetic flux linkage. So it's delta phi over delta t. The magnetic field around the coil going to zero gives us a change in the magnetic flux linkage. So there is change in phi. And given that this change is happening rapidly, delta t is very small, which makes a large EMF being induced. And this large EMF is greater than the 200 volts required for the lamp to flash. So we can see the neon lamp flashing. And it only flashes once, because once the magnetic field goes to zero, it no longer changes. And without a change in the magnetic flux linkage, there can be no more EMF induced, and the lamp stops working.